Welcome here to Boston TCT2022. I'm Ole De Backer. I'm an interventional cardiologist from Rikshospitalet, Copenhagen University Hospital. And I'm here on behalf also of the PREDICT-LAA investigators as we came to present the exciting results of the randomized control PREDICT-LAA trial. In order to explain the main objectives of the trial, I think it's first of all important to say that when performing transcatheter or percutaneous LAA closure, there are two concerns. There are either peri-device leaks or device-related thrombus. And that's things we want to mitigate that risk or we want to reduce to an absolute minimum. So the setup, the idea, the aim of the study was to see whether use of pre-procedural computational modeling could reduce this risk of peri-device leaks and device-related thrombus, and could also optimize the procedural efficiency. So in short, I could say it's a randomized trial. It's the first randomized trial using computational modeling. It was involving 200 patients. They were randomized 1-to-1. So 100 patients got a standard planning for their percutaneous LAA closure. 100 other patients got a CT-based computational modeling planning of the procedure. When we come to the key results of the trial, so the primary endpoint was set on a CT endpoint at 3 months, so at 90 days post-procedure, and there was either it was a composite endpoint, primary endpoint of leak distal of the amulet, because the study was done with an amulet device, leak distal of the amulet lobe, and or device-related thrombosis. That was the primary endpoint. Secondary endpoints were some procedural efficiency outcomes and safety outcomes. Also on CT, we were looking to complete LAA closure. That's actually what you really want to obtain with the procedure. And then also device-related thrombosis and retraction of the disc, amulet disc into the lobe, and some clinical endpoints. So this was the setup of the study. So if we go to the key results, then we can say that, first of all, for the primary endpoint, there was a 31% relative risk reduction of the primary endpoint, so seen less severe leaks and less device-related thrombosis. We obtained a p-value of 0.08, so we just missed the statistical significance, but we had a 31% relative risk reduction. On the other hand, we had a significant increase in the number of complete LAA closures. So this increased from 44% in the standard arm to 61% in the computational CT simulation arm. So that's an increase of 44%. And then also, I would say the most impressive was even the effect on the procedural efficiency. There was used significantly fewer LAA closure devices in the simulation arm, significantly fewer device repositionings, 50% fewer less repositionings. There was 25% less contrast medium used, 25% less radiation given. And last but not least, I would say we could prove that in the CT simulation arm, there was 100% procedural success without major procedural complications. First of all, I think as a conclusion, we can say that this is really the first randomized controlled trial showing that computational modeling can have impact on procedural efficiency and outcomes. And this is now specific for transcatheter LAA closure, but I think the more complex procedure you're going to do, and I talk about doing percutaneous mitral or tricuspid valve implantations, for example, the more this benefit of computational modeling can be expected. So this is just the start of something bigger, and you will see this being implemented and being used more and more in the future.